Welcome to the weekly challenge videos. If you like this kind of content, please like or subscribe. And if you'd like to see even more of these challenge questions, I have a lot more on my courses website, link in the description below. An object is thrown straight up in the air at time t equals 0. It reaches a maximum height of h0 and lands at a times t equals tf. So let's draw a picture. We're going to have an object that's going to go up and then down, and it reaches a height of h0, and then it lands here at time t equals tf. Derive an expression for the initial velocity that was thrown in terms of tf and g. So here is one where we're going to use the kinematic equations, and we have to be very careful about what's our initial and our final point, because they really give you kind of two pieces of information, the h0 and the tf in this problem. So for this one, what I want to do is I want to say this is the start and this is the final point. So what is the vertical displacement? It's actually 0. Between here and here, it actually travels no distance vertically. The initial velocity is what we want to solve for. The final velocity is not given. The acceleration is downward at, we could say, negative g. And t would equal tf. Right? Because if I say up is positive and down is negative, then the acceleration downward negative g. So then we would use, I want to find v0, so we would look at this equation. Delta x equals v0t plus 1/2 at squared, like this. So we'd say 0 is equal to v0tf minus 1/2 g tf squared. And I would solve for v0. So I'm going to move this to the other side. And then divide out one of the tf's. Okay. So we didn't use h0 for that one because in this part they wanted you to do it in terms of tf and g. In the second part, they would like you to derive it in terms of h0 and g, so in terms of the maximum height. This time we're not going to use these as the start. We're going to say this is the starting position and then this is the final position. So then when we look at our variables, the vertical displacement between there and there is h0. The initial velocity is what we want to find. V is unknown. Well, actually, we know the final velocity because the final velocity at the top here is 0. The acceleration is, again, negative g. And t is sort of not given in that scenario. We don't want to deal with t. So because they don't want you to use tf. They just want you to in terms of h0 and g. But I have 3 variables, and I can find the 4th variable using this equation. So I'd have 0 is equal to v0 squared plus 2 times negative g times h0. And then just move this to the other side. You would get v0 squared is equal to 2gh0. Or v0 is equal to root 2gh0. Finally, C, sketch a graph of the object's velocity as a function of time. Here, you would look at something like this. You would say, it starts with an initial velocity. Here, we'll say upward is positive. And then it has and then it lands. So it has a slope of negative g then, right? Because the slope is, this slope here should equal negative g. So it should be downward sloping. Here's where it reaches maximum height. And then it keeps going and it starts falling downward, so it has negative velocity. But it's a straight line because the acceleration is constant the whole time. That's it.